Hello everyone, let's understand today why is Kelvin considered the thermodynamic temperature scale. The zeroth law of thermodynamics, it says if two bodies, say the body A and body B, they are in thermal equilibrium with the body C, and then we can say that uh, they are also in thermal equilibrium with each other, right? The body A is in thermal equilibrium with body B. It seems silly that such an obvious fact is called one of the basic laws of thermodynamics, but it cannot be concluded from other laws of thermodynamics, and it serves as a basis for the validity of temperature measurement. This is how we use the thermometer to measure the body temperature. Now we have the temperature scales to measure this temperature. We have four common scales. We have degree centigrade scale, which is Celsius scale. We have degree Fahrenheit scale. We have the Kelvin scale. We have the Rankine scale. These are the four common scales which are used to measure the temperature. So out of these four scales, the thermodynamic temperature scale is the Kelvin scale. And in thermodynamics, we don't use the degree Fahrenheit and Rankine. We use the Kelvin scale. Rankine can be used, but degree and Fahrenheit, they are not the thermodynamic temperature scales. Rankine is also a thermodynamic temperature scale, but we use this in English system. But why is Kelvin, or in English system Rankine, considered as the thermodynamic temperature scale? In thermodynamics, it is desirable to have temperature scale that is independent of what? Of the properties of substance. So this means the Kelvin is independent of the properties of the substance. That is why the Kelvin or the Rankine are considered as the thermodynamic temperatures. Now let's understand this with the help of pressure versus temperature plot. Let's take an example of the gas A. This gas has been put into a fixed volume. V is constant, right? And you can see when there is rise in pressure, right? Rise in pressure, temperature is rising. No, temperature is increasing. So this, or if we decrease the pressure, the temperature will decrease. So here we can conclude that degree centigrade is pressure dependent, right? So at sea level, water can be boiled at 100 degrees centigrade, but when we move away from the sea level, this temperature will change. Now let's take two major data points. Two major data points of this gas which has been kept in constant volume, and use the linear equation for the extrapolation, right? After doing this, this line will intersect this temperature line at minus 273.15 degrees centigrade. So this minus 273.15 degrees centigrade is the point which is nowhere dependent on the pressure. So at this point, the internal energy of a substance will become zero. So Kelvin has taken this reference point. So he took this point as 0 Kelvin, which is known as absolute zero. As this is independent of the pressure, such a temperature scale is called thermodynamic temperature scale. Now let's compare the all four scales of temperature. So I took here two points. One is the triple point of water, which will be discussed in coming lectures, and the absolute zero, which we have discussed right now. So at absolute zero, the degree centigrade is equivalent to minus 273.15 degrees centigrade, and at the same time the Fahrenheit will be minus 459.67, and Rankine will be 0, right? So similarly, at the triple point of water is 0.01 when we talk about the degree centigrade, and it becomes 273.16 for the Kelvin, and for the Fahrenheit it is 32.02, and for the Rankine it is 491.69. So we have the simple conversion formulas to make the comparison. We have simply T Kelvin is equivalent to T degree centigrade plus 273.15, right? And simply we have the T Rankine is equivalent to T Fahrenheit plus 459.67, right? Also we can use the T into Rankine is equivalent to 1.8 T Kelvin, right? And similarly T Fahrenheit, degree Fahrenheit is equivalent to 1.8 T degree centigrade plus 32. So these are the formulas which we use to convert one scale into another. There is one more important thing to remember, that is the delta T Kelvin is equivalent to delta T degree centigrade. Why? Because when we do comparison of magnitudes of the temperature scales, we know that 1 Kelvin is equivalent to 1 degree centigrade. This is the magnitude of the scale, right? So the change in temperature in Kelvin will be change in temperature in degree centigrade. Similarly, delta T Rankine is equivalent to delta T degree Fahrenheit. Why? Right? Why? Because the magnitude of the Rankine and the Fahrenheit is 1.8. Rankine is equivalent to 1.8 degree Fahrenheit. So you can use these things, these concepts in numericals. Thank you. This is all about today's lecture. Thank you for watching.